How's everybody doing out there? So in chapter 4, we're going to continue our study of probabilities, but in this case we're going to be talking about things that are a little bit more complicated in terms of being able to just count what the probabilities would be. So the way we're going to do them, they won't end up being complicated, but it is actually allowing us to deal with fairly complicated situations. So in my little preface above here, I've got that if we roll a single die, for example, the probability of being able to find what a single die roll is, it's pretty straightforward. We've done that a bunch of times. But what if we rolled, say, 5 dice at the same time, and we're trying to figure out what's the probability that all 5 of them come up odd? What's the probability that we get 3 threes or something like that? So that's going to be a lot more complicated, but because of a little method that we're going to use, it actually ends up being pretty straightforward in terms of how to calculate them and stuff. So just to get a little background information on what we're going to be using for our probability distribution functions, so we need to remember a random variable is just a way to describe all the possible outcomes of a statistical experiment along with their probabilities. So a discrete random variable is a random variable where there are a finite number of outcomes. So again, they have to be counting numbers, 0, 1, 2, 3, no decimals, none of that kind of stuff. So when we're talking about our variables, we're going to use uppercase letters to represent our variables, so like x and y. And then we're going to write what this means in actual words. So if we look at this little example below, we let x equal the number of heads you get when you toss 3 fair coins. That would be a verbal way to describe what's going on. And so our lowercase x is going to represent all the possible heads that we can actually get for these guys. So our numeric choices are we could get 0, we could get 1, we could get 2, we could get 3. So our capital letters are always going to be a written description of what's going on in words, and our lowercase variable is always going to be kind of a numeric, like what's the numeric outcome of these possibilities. And so again, from these, we're going to be able to use these as a way to help us calculate more complicated probabilities. All right, so let's look at what a probability distribution function is. So with this one, we've got a little example in our box here. So a probability distribution function is a table that lists each possible outcome and its probability. So for example, if we assume we rolled a fair 6-sided die, x is just the number that comes up. Lowercase x would be, of course, that top row, the numbers 1, 2, 3, 4, 5, 6. And since a die has an equal likely a chance of occurring for each one, then we just end up with 1, 6, 1, 6, 1, 6 for each and every one of them. And then from here, we're going to be able to do some stuff with it. But this is just kind of a setup of what a probability distribution function looks like. All right, so I'm going to help you set up practice 1. And then I'm going to let you work on practice 2 and practice 3 on your own, just to make sure you've got the hang of it. So for practice 1, this goes back to when we were dealing with sample spaces of our rolling 2 dice at the same time. And so our sample space looks like above. And so our capital X is going to be the sum of the 2 values. So if I look, then my lowest possible roll I could have is this 1 plus 1, which is going to give me a 2. So I'm not going to have anything smaller than a 2 on my list. And if I go over here, 6 plus 6 gives me 12. That's going to be my biggest possible roll that I can get. And then I can have anything else that lives in between them. So I can have either 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and then finally 12. So now what we want to do is see what the probability of each of these different possibilities would be. So again, if you remember, we've got 36 outcomes total for this. So our bottom number is going to be something over 36 for each one of them. So what we want to do is just count how many of each possibility there is. And so if we look, there's only the 1 times 1, so there's only one way to roll a 2. So this is just going to be a 1 out of 36. Now the cool thing is about the chart, and the reason I laid it out this way is because everything kind of runs along a diagonal. So for example, if I wanted to figure out all the possible ways to roll a 3, if I figure out where my first 3 occurs on the left and just go up at a diagonal, that's going to give me all the possible 3s that I can get. So if I notice, there's just 2 possible 3s that I can roll out of 36. And so if I do the same thing with 4, so there's my first 4. And so if I go up at a diagonal, I'm going to hit those 3. So I've got 3 out of 36. If I go to 5, so I'm going to end up with, it looks like 4 out of 36 for 5. For 6, so I'm going to end up with, it looks like 5 out of 36. And then finally for 7, I'm going to end up with those 6. And so now, when I go to 8, notice I've run out of numbers in the first column, so I'd have to go to the second column. So my second column, my 8 starts there. So if I follow it along the diagonal, so it actually drops back down to 5. And then this will continue the rest of the way. So 4 out of 36, 3 out of 36, 2 out of 36, and then finally 1 out of 36. All right, so make sure you understand that. If you don't have questions, just let me know, and then try practice 2, practice 3, and then we'll come back and see how we can use these probability distribution functions to actually answer some questions. So I'll see you in just a little bit.